there. We're going to talk about the second day of 6.4. I hope first day went well for you. The first recording was about tables and just identifying what was there. So now we're going to do some application with it. All right, so just reviewing the two formulas. Your growth formula, remember, has a plus sign, so this number inside the parenthesis will be bigger than 1. And the decay function has a minus sign, so the number inside the parenthesis will be less than 1. Remember, you can identify as something as a growth or rate by looking inside the parenthesis. If that number is greater than 1, it's a growth. And if that number is less than 1, it is a decay. All right, so write the function that represents the situation. So it said sales of $10,000 increased by 65% each year. So this is my initial amount, A. Increases implies growth. And 65% is my rate. I need to change it to a decimal. So I'm going to move the decimal 2 places forward. So my rate's going to be 0.65. So my formula was A times 1 plus, it's an increase, the R to the T. So Y equals 10,000 times 1 plus 0.65 to the T. So as far as I can go, because I don't know how many years, would be this equation right here, this exponential equation. And it's exponential because T is the exponent. All right, and then number 6, why don't you push pause and try number 6? And then I'll do it too. So my population is 210,000. That's my A. It's increases, so it's growth. 12.5% is going to be my R, and I'm going to move the decimal up 2 places. So 0.125. So Y equals 210,000 times 1 plus 0.125 raised to the T. So my final answer, all I have to do now is add what's in the parenthesis, and that's going to be my answer right there. All right, same thing, but this looks like these are decays because they both say decrease. So we're going to use the decay function. Remember, the only difference is the minus sign inside the parentheses. So 100,000 is my A, and this is my R. I move the decimal up 2 places. So Y equals 100,000 times 1 minus 0.02 to the T. So my final answer here will be Y equals 100,000 times 0.98 to the T. This is my answer. Right? And another decrease, so that's a decay as well. 100 is my A, and 9.5 is my R. I move the decimal up twice. So Y equals 100 times 1 minus 0.095 to the T. So Y equals 100 minus 0.995 raised to the T. How about 915 is better? Yeah, 915 is better than 995. And you could just stick this into Desmos. That would give it to you. All right, so those how you set them up. Okay, so now we're going to do a little evaluating. So it says identify the initial amount. So this time they give us the function and we say what everything is, and then we evaluate when T is 3. We're going to use the calculator for this. So A is going to be my initial amount, 575. And R is 0.6, and it says to give it as a percent, so I go 2 places to the right, so 60%. So I can type this into Desmos just like it is. I'm going to evaluate when T is 3, so I'm going to put a 3 here. So I'm going to Desmos and typing it in. So 575 multiply by 0.4 raised to the 3rd power. And that gives me 36.8. Okay, that's a huge decay. But, I mean, it is something, whatever this is decaying at like 60% over 3 years. That's a lot of decay. So that was 36.8. Started at 575, and now it's down to 36.8 at a 60% decay after 3 years. Okay, so this one would be a little bit different. Now, remember, in here is supposed to be 1 minus R. So this little number, if I go into Desmos and do 1 minus 0.995, will give me the R. So let's change colors. So my A is 700, And my R is 1 minus 0.995, which is 0.005. And then I make it a percent by moving it over twice. So 0.5% is my R, is what I'm going to use. All right. And then here, I put the 3 in there and I type this baby in. So go back to Desmos. So 700 times 0.995 raised to the third power. And this is is that correct? Let's make sure I typed that right. 700.995 to the third. Yeah, that's right. So 689.55. I think it said nearest tenths. Yeah, nearest tenths. So 689.55. This is the hundredths. This is the tenths. So I underline point. So 5 is high enough to pull it up. So the final answer would be 689.6. Now, this number is much closer to this number, and the reason is over 3 years, the decay is only happening at 0.5%, where this decay is happening 60%. That's a high number compared to 0.5%, which is why there's a big difference in these two numbers, and there's not a big difference in these. But notice the answer is still smaller than the initial amount because it's decay, and the answer is still bigger than the initial amount. Oh, we haven't done any growth step. We'll look at those next. Okay, so it says the inaugural attendance of an annual music festival is 150,000. That's my A. And the attendance Y increases by 8%. That's my R, and I'm going to move it up twice each year. So if we write the function, that would be Y equals 150,000 times, and it increases, so that's a growth, to the T. So I finally end up with 1.08 to the T. That's my function right now. Okay, so it says how many people will attend the festival in the 5th year? Okay, in the 5th year. So, 5th year. Let's figure that out. So T is going to be 5. So we're going to plug this in. So Y equals 150,000 times 1 plus 0.08 to the 5. So we're just going to plug it in. 150,000, 1.08 to the 5th. Okay, let's see if we can remember that to type that in. 1,000 times 1.08 and then raised to the 5th power. No comma. There we go. So 22399.2. Y is 22399.2. And we're talking about people. Oh, and it also says round to the nearest 1,000. 1,000 is right here. So if we point, 3 is not strong enough to pull it up to a 1. So my answer then is 220. 220,000 since I'm rounding there. But honestly, if I were really rounding and it didn't say this, I would have rounded to the nearest person. So it would have been 220,399 because 2 again is not strong enough. All right, it says a website has 500,000 members in 2010. So my A is 500,000. The number Y of members increases, this is growth, by 15%. That's my R, so 0.15. Write a function that represents the situation. So Y equals 500,000, 1 plus 0.15 to the T. So when I add that inside the parenthesis, I end up with this as my function, my growth function. And it's growth because it says increases. How many year will be there in 2016? So what did it start with in 2010? So 2010 was the first year. 2011 is the second. 2012 is the third year. I need more room. 2013 is the fourth. 14 is the fifth. 15 is the sixth. 2017 is the seventh. So we're going to do wait a minute, 2016 is the seventh. Yeah, so this T is going to be 7 here. because 2010 was 1, not 0. So we're plugging it in. So y equals 500,000. That's a big comma. 1.15 to the 7. So let's type that in. 500,000. 1.15 raised to the 7. Remember, we know that number is going to go up because it's growth. So it goes up to 1,330,009. Let's see if there's any rounding. 1,330,009. Round to the nearest 10,000. Well, 10,000 is here. So my answer then would be 1330, and the rest of these become zeros. So did it go up? Well, yeah, it was 500,000 and it went up to over 1 million. So yeah, it definitely went up. All right, the value of the car is 15,000. That's my A. It loses, that's a decay word. 10%, that's my R. Move the decimal up twice, 0.10. So if I write the function, I have to use the decay, the minus, not the plus. So y equals 15,000 multiplied by 1 minus 0.10 to the t. So 1 minus 0.10 would be 0.9. Or 0.90 if you'd rather. And find the car after 4 years. So we're going to evaluate that function at 4. Remember, since it's a decay, the car's value is going down. So when I stick 4 in there for Desmos, so 15,000 times 0.9, let's remember that. 15,000 times 0.9 raised to the 4. The number should be smaller, and it is, 9841.5. And I don't think it said to round. 9841.5. Find the value. And this is money, so I'll put a dollar sign and a 0. So anytime you buy a car, that car depreciates or gets worth less each year that you drive it. So that makes sense. The car value went down. Okay, and then these are the last couple, and this is on the test, so make sure you understand this. So I have a different formula that is also compound, or that is also exponential, because there are variables for the exponent. So press pause and write this formula down in your notebook so you have it when you take your test. So P stands for principal, R stands for rate, T is time in years, and N is the number of times the interest is compounded per year. So you're going to look for words like annually, which means 1 time a year, biannually, which means 2 times per year, semi-annually, which means 2 times per year also. What else do we have? Quarterly. That means 4 times a year. Monthly. That means 12 times a year. Okay, and that mostly applies to your N, these words right here. You could have tri-annually. That means 3 times a year. You don't see that very often. Okay, so if you have it all, I put the formula on the next page too, and then we're going to pull out information and stick it all in there and see what happens. Okay, so write a function that represents the balance after t years. So we're just writing. We're not using the calculator. So t is my deposit. That is my P. And this is my R, moving the decimal up twice, 0.05. And deposit earns 5% annual, compounded quarterly. So my N is 4, because quarterly is 4 times a year. So I start with, so y equals P, and then it was 1 plus R over N, 1 plus 0.05 over N, and it was raised to the NT, so 4T. This is my equation. I just need to simplify this in here. That's kind of a mess. So 1 plus 0.05 over 4. Let's see if I can get that simplified using the calculator. So 1 plus fraction 0.05 over 4. And it gives me 1.0125. 1.0125. 1.0125 to the 4t. So this is my equation right there. So honestly, I just put this into the calculator and I typed it exactly like it's written. Okay, so press pause and try 18. See what you come up with there. So 6,200 would be my A, or actually it's my P, my initial amount, my principal. Deposit that earns 8.4, that's my R. Move the decimal up twice. That's my R. And it's compounded monthly, so my N is 12. Okay, so if I use my same formula, 6,200, 1 plus, so it is 0.084 over 12 times 12t. So I'm just going to put this part right here into the calculator. I hope that's what you did too. Let's see if I can remember it going back and forth. So 1 plus fraction 0.084 over 12. So 1.007. So I end up with y equals 6,200 times 1.07 to the 12t. This is my answer. I hope you got that. Did you get it? Okay. If you're having trouble, there's some of these in the big ideas. There's a video you can watch there to have somebody else explain it to you. Just remember that your principal is like your A and your R is exactly the same. You change that to a decimal. Your T is the same, and then you have to include that N in there. And you're looking for words like annually, biannually, semi-annually, quarterly, monthly. We did some that were like that at the examples, the quarterly and the monthly. Okay, we're all finished. You are going to big ideas now to work on those growth and decay and the compound interest problems. And then there is a quiz you can take when you're finished. I think there are 8 questions. And if you have any questions, I know that I'm not here this week and you're just watching videos. So if you have questions, you can come to iPass. Thanks very much. Have a great day.